Okay, in this video we're going to finish up section 5.1, exponential functions and their graphs. And today our main focus is going to be on the one-to-one property and our very special base e. So, from figures 5.3 and 5.4, you can see an exponential function is always increasing or decreasing. I can't remember if 5.3 and 5.4 were on the last video or not. But when we graph exponentials, if we have a to the x, a to the positive x, it's going to be going uphill, an increasing function. If, on the other hand, we have a to the negative x, it's going to start high and then decrease as we go toward the right. So they're always increasing or decreasing. As a result, the graphs pass a horizontal line test, and therefore the functions are one-to-one functions. Remember, we had the vertical line test was, is it a function or not? Here, with the vertical line test, we only want to intersect our graph at one point, and it is therefore a function. There is another test, this horizontal line test. Can we draw a horizontal line? And let me switch to green here. Can we draw a horizontal line that only passes through the graph at one point? And here it does pass that horizontal line test. So we can use this, what we call the one-to-one property, to solve simple exponential equations. And what this one-to-one property tells us is, for a is greater than 0, if our a value is positive and not equal to 1, if a to the x is equal to a to the y, a to the x equals a to the y if and only if x is equal to y. So the big idea here is, if the bases are equal, you can set the exponents equal to each other. So how would we use this? Well, let's look here in example 4, part A. We have 9 equals 3 to the exponent x plus 1. Well, our one-to-one property says if we can get those bases the same, we can set the exponents equal. Well, here our base is 3 to the x plus 1 power. Is there a way I can rewrite 9 so it has a base of 3? 3 to what power is 9? Well, of course, that's 3 squared. And now that we have the bases are equal, we can concentrate and set the exponents equal. So we can set 2 equal to x plus 1. And solving for x, real simple, subtract 1 from each side, x equals 1. So that is the one value of x that would make this a true statement. Now let's see what's going here in part B. 1/2 to the x power, 1/2 to the x. Can we rewrite 8 as some base of a half? Well, that might be tricky to do, but let's think reciprocals here. What's the reciprocal of 1/2? Well, that's 2. Can I rewrite 8 as 2 to some power? Well, of course, that's 2 to the third. Now, we do have a property here. If I have a fraction, and this 1/2 is a fraction, if I want to flip the fraction upside down, I negate the exponent. So I can turn this 1/2 over into 2 over 1, or just plain old 2, if I make the exponent negative. Now it's negative x, and that's equal to 2 to the third power. So here again I have the bases equal. 2 and 2 are the bases, so I can set these exponents equal. Negative x equals 3, and I multiply through by a negative and get x equals negative 3. Now we have a natural base e. We've been working with bases like 2 to the x, or 3 to the x, or 4 to the x. Now we have some very special numbers like pi. Pi is irrational, never ends, never repeats, 3.14159, blah, blah, blah. Very special mathematical number. E, this natural base e, is also a very special mathematical number. It is 2.71828, blah, 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 never ends, never repeats. So in many applications, the most convenient choice for a base is the irrational number e. This number is called the natural base. The function is given by f of x equals e to the x is called the natural exponential function. Its graph is shown down here in the figure. Be sure to see that for the exponential function f of x equals e to the x, e is the constant 2.718281828 ... where x is the variable. So we look down here at the graph. Just like all other exponentials, we do cross the y-axis at 0, 1. And then when we plug in an x value of 1, e to the first is e. If we had room on the graph and we did plug in a 2, this would be on our x-axis at 2, we'd go way up here somewhere, and this point would be 2 comma e squared. Working on the negative x values, we plug in, here's x is negative 1, e to the negative first power, or some might prefer to write that as negative 1 comma 1 over e. Our next value here on the negative side is negative 2 comma e to the negative 2. Or again, some people might like to get rid of that negative exponent and write that as 1 over e squared. So that is our natural exponential function. On example 6, we're going to work with the calculators and the natural exponential function. So we're going to use a calculator to evaluate the function f of x equals e to the x for these indicated values. First, x is negative 2. We plug negative 2 into the function e to the x. So we're going to punch into our calculator e to the x and then negative 2 enter. And our display should read 0.1353353. And we'll do the same thing for negative 1. E to the negative 1, punch it into the calculator, negative 1, and we get 0.3678794. And let's try some fractions in there. E raised to the power 0.25 will give us an output of 1.2840254. And now let's try a negative fraction, e raised to the negative 0.3 power. And that's going to give us 0.7408182. Now in example 7, graphing these natural exponential functions. Sketch the graph of these natural exponential functions. The first one is f of x is 2e to the 0.24x power. And g of x, now we have a fraction in front, 1/2 e, and now our exponent is a negative decimal, negative 0.58x. Okay, to fill in the table, and doing that by hand, that would be pretty hard, so we are going to rely on the graphing calculators. To sketch the graphs, you can use a graphing utility to construct a table of values, as shown. Remember, you would put your function into the y editor. So you'd go to the y editor on our TI-89s, that is the green diamond F1 key. Green diamond F1 key, and we'll have our y equals. And we want to plug in 2 times e, and then we put in our exponent, 0.24x, and then plug in these x values on the table. Remember, for the table, you want to make sure you're in ask mode, so you want to do green diamond F4, and make sure your table is set to ask and not auto. And then you'll go green diamond F5 to get to the table. And on the table, you want to plug in these x values, negative 3, negative 2, negative 1, 0, 1, 2, 3. And these, for f of x, will be your output values, these decimals. And when we notice reading left to right, they're smaller, and they get bigger and bigger and bigger. We can also put in the g of x function with the negative exponent. Plug that right into the calculator, and we'll have our same x values set up from the f of x function. And we will see these output values, starting at 2.8, and we're going downhill to 0.088. So this function starts out bigger and gets smaller as we go. And we can also check out the graphs of these functions. So here's our exponential with a positive exponent going uphill, and our exponential with a negative exponent, of course, going downhill, left to right. And notice these are not crossing the y-axis at 1, because it's not just e to the x. We got some other stuff going on with that, the exponent. So for some practice problems, first use the 1-to-1 property on number 51 and solve for x. In the next two, it says use a graphing utility to graph the exponential function. And then I put in a little extra there. Go to the table, diamond key F5. What is the value of the function when x is 11? And for 41, you're going to do the same thing. What is the value of this exponential function when x is negative 8? So pause the video, try the practice problems, and then start it back up and see if you got them right. So in 51, we have 3 to the x plus 1 power. What we got to ask ourselves is, can we rewrite 27 as 3 to some power? Well, that's going to be 3 to the third. 3 to the third is 27. And now that the bases are the same, we can set the exponents equal. X plus 1 equals 3. Subtract 1 from each side, x is equal to 2. That's our only solution. So for the other ones, of course, it was just use the graphing utility, graph the function, and then I wanted to take it a step farther. This first function, if you go to the table and plug in 11, what does this value have when x equals 11? Well, that's going to be y equals 3 to the power, 11 minus 2, or 9, 3 to the 9th power, so that's going to be pretty big. And then we add one more. And if you did everything right on your calculator, you should get 19,684. In the next one, we wanted f of negative 8. So it was going to be 3e, and then our power was going to be negative 8 plus 4, or that's going to be the negative 4 power. And if you punch everything right in the calculator, you should get 0.05495. The homework for this section, I was not too thrilled with the problems in the book. I found some extra problems in other books that I do have. So for this section, we will have a handout for the homework.